I have a major problem with kissing. No, not like that. At least I don't think my wife thinks so. I mean, keeping it simple, stupid. I'm the stupid. For the life of me, I can't let even the smallest problem have a simple solution. This shop is riddled with evidence of my ego having a little too much authority. And to be honest, it's killing me. I want to make things that work and are better without spending all my time designing them. So today, I'm fixing this mess of tap wrench paraphernalia. And for once, I'm just going to give it a kiss of ingenuity. Welcome back to Inheritance Machining. Alright, let's look at our problem first. This is a tap. It cuts threads in holes for bolts. If you have even one tap in your life, you probably also have a tap wrench of some sort, because taps need torque and wrenches make torque. I have a lot of taps, with a lot of different sizes, so I have a lot of wrenches. And herein lies the problem. Somewhere along the road, someone decided that the best way to handle all the different sizes of taps was to make different sizes of wrenches. But this just seems stupid, and I don't like stupid. But there's yet another problem. This type of wrench, called a T-handle tap wrench, is used for all the smaller taps that don't have a butthole. Sorry, a center drill. This center is used in most setups to keep the tap straight, and reduces the risk of breaking. So the T-handle supplements this with a center of its own. But this comes with a cost. Length. Just bringing this tool into the equation means you have to make room for it, which in some cases isn't even possible. To further compound the problems, driving the biggest of the smallest taps, the ones without centers, is a real bear when all you have to grab onto is this dinky little rod. A bigger wrench like this would help, but again, no center. So just to accomplish the common task of tapping a hole, we need too many tools that take up too much room and are too uncomfortable to use. And I think this is a huge problem. But just because it's big doesn't mean it needs a big solution. Remember my goal this time: keep it stupidly simple. I want just one tool that's small and easy to use that fits all of these taps, and I have an idea. Actually, 3 ideas. Let's make a demo. This will be helpful for explaining what I want to make, but I also just want an excuse to use the new H2D that Bamboo Lab is sponsoring this video with. Bamboo Lab is renowned for always improving their technology, so I wanted to see what the latest and greatest is all about. Not only does the H2D come with a massive build volume that can nearly fit my X1 carbon, but it comes with a dual nozzle extruder. Or more accurately, 2 separate extruders. Paired with a pair of AMS2 Pros that feature active filament drying, now I can print 2 colors or materials at the same time without purging between them. That means no more veering away from multicolor prints because they're 95% waste. I also like this because I can print 2 different colored parts at the same time. Instead of having to keep track of multiple prints, I can just set up one print and come back when everything is done. And the quality is everything I would expect with Bamboo's 2nd generation print technology. This demo is literally the first print off the H2D, and it goes together perfectly. Confident in its capability, I couldn't resist putting this bad boy to work on some other improvements around here as well. Like some covers to keep all the chips out of the T-slots on my mill. Bamboo's new flexible TPU is designed specifically for their AMS unit, so no more fussing with an external spool. I just load it and let the printer do everything, exactly how I like it. And again, the gargantuan build volume means no problem printing these extra long parts. But what about TPU and PLA together? I wanted this tool tray for my mill to be both stiff, but flexible where it snaps into the T-slots. No problem for the H2D. I can use the beam interlocking feature to combine both PLA and TPU in the same print. Now I have a tidy little spot for my active tooling that doesn't get covered in chips. I was on such a roll with my new toy that I may have gotten ahead of myself. I went ahead and printed a tool holder for this project's final outcome. Gridfinity, of course. And as expected, the labels came out perfectly. Now you might be watching all this and thinking, man, I don't want to have to model everything I print. Good news for you. You don't. Bamboo Lab also hosts the largest ecosystem for makers that includes MakerWorld, which is a platform with hundreds of thousands of user-designed models free to everyone. Trust me, I use this a lot. Use the special link in my description to check out Bamboo Lab's H2D and all their other renowned printers and supplies. So this is actually what I'm going to make, but smaller and out of metal. And yes, it does look like a T-handle tap wrench. That's because that's exactly what it is, but this one solves all the problems I mentioned earlier. You might already be picking up on how, but I don't want to give away all the juicy details just yet, so let's get to work. The first thing we're going to need is some metal. A2 is the flavor of the day. One better than your average steak sauce. It's hardenable, and where tools are concerned, hard is good. But more than hardenable, it hardens without distorting much. Which means I won't be putting a bunch of effort into making something nice and straight, only for it to become a banana in the oven. With our stock satisfactorily supported, let's set the shaping. First, taking off the outer layer of unneeded iron to reveal that perfect major diameter underneath. And then just a little bit more for good measure. Next is the threading tool, but not the threads. Not exactly kosher for turning, but it has the 30-degree angle I'm looking for, and that's obviously more important than following the rules. Lining it up takes a good eyeballing with the end of the stock, then I can relieve the pre- and post-threaded sections. "18 teeth to an inch is what the dentist ordered, so we'll gear up for that, paint the target so we don't miss, and we're off to the braces. Now the whole point of this thread, well, let's refer to our demo. There's some tapered geometry in here that in combination with the slits causes the diameter to shrink when tightened. Kind of like a collet. Actually, exactly like a collet. I'm making a collet. But collets need tapers, and with the thread on our metallic doppelganger to size, we can do just that. 15 degrees seemed like an appropriate angle, so I'll set up the compound slide, then throw the lathe in reverse because for some reason I decided I needed to use the boring bar for this. Now we can get to the real meat and potatoes. The thing that makes this wrench so revolutionary. The one thing that has never been done before. Are you ready for it? To make this wrench compatible with every tap under 3/8, I'm going to drill it out for every tap under 3/8. How has nobody done this before? I will admit this did take a bit of noodling. The collet doesn't actually grab on the round part of the tap. Instead, the corners of the square drive fit in the slits. But with some careful planning, I was able to narrow this down to just 3 different diameters, which should, in theory, cover all the taps. But I won't know the answer to that for quite a while. So let's get back to the part and move forth to the mill. I want to take advantage of all this extra shaft length while I have it for some firm grasping. There's always the chance that one's part will get yoinked out of the vise when milling, and that probability only increases when we start messing with slitting saws. Big teeth, a lot of torque, you see the danger. That went surprisingly well, and now we have ourselves a collet. Since I'm already situated in this square block, I'll also square up the end. First using a roughing mill, then revisiting the finish with a fly cutter because that's not going to fly. Now that looks a lot better. Last for the mill is to drill. This isn't a standard T-handle tap wrench, but it will need a T-handle, so a precisely reamed hole is in order. It's starting to look like a thing. Let's round this out back at the lathe. The first part is easy, parting. The trick now though is how do I hold this to finish the other end? I can't grab on the slit end because it will just collapse, but maybe if I put a drill in here to prevent that. That actually worked. Truthfully, I was less worried about being able to hold it and more worried about holding it straight. Because after facing the end and popping a chamfer on here, we have to add what is arguably the most important feature of this wrench. The center drill. Remember, this is the one feature that keeps the tap straight. No point in even making this wrench if we don't include it. Now that is finished, but I do have one more thing on my sleeve, and I won't give it away just yet, but it requires a tapped hole in the end. And tapped holes require tap wrenches. Of course, the one I need is too big for this wrench, so I'll have to resort to one from my collection. There is a cruel irony in using this wrench to create its replacement, but just remember folks, tools don't have feelings. One tap wrench body complete. My initial impression is it's going to work for all my taps, but not without the nut, so let's whip that guy up next. Using bronze this time, partly because it's got some good bearing properties that should make it feel real nice, but also because it will look real nice. With the diameter whittled down, I can freshen up this wobbly old center, then draw out clear to the other side. This hole isn't overly critical, just needed to make some room for our next guest. A threading tool. Except this one is a little boring. Again, this tool isn't meant for general turning work, but it fits the bill and there isn't much to prepare in here. Though we do have that matching taper to take care of. The angle here is subtly different though, 1 degree in fact. This will hopefully compensate for the angle change that the taper of the collet will go through as it closes. Keeps the force out near the tip and all, where it's strongest. Let's thread. I love making both halves of a threaded connection. It lets me make sure the fit is perfect. You know, because sometimes you miss the mark slightly on the first half, so you can just fix it on the second. Not saying that happened this time, of course, just that it happens. I can't take this whole bar with me like the last part, so I'll turn down a concentric reference on here before parting this off and we can set up in the mill. Using the hex block this time, because nuts. No sense in dilly-dallying with anything but the fly cutter this time to nail the finish on the first pass. Then back to the lathe for the final touches. I'm talking about the tapered nose, of course. I love me some big chunky cuts in bronze. The last thing is just cleaning up the parted face to make it a little less dangerous. That's the nut complete. Pretty simple, right? I mean, what did you expect? It's a nut. But knowing me, this could have been a 6-part series with 11 side projects. So a simple nut made simply is a win for me. But more importantly, it seems to be working. At least the closer fitting taps seem to get snug. But I'm hesitant to gronk down on this for the looser taps. I don't want to bend the ears of the collet. What will help with that is some heat. Heat treating this steel body should raise the yield strength, meaning it will flex a bit more before permanently bending. But that only works if you do it right, and for the first time ever, I'm going to do it right. Wrapping the part in stainless steel foil will prevent it from decarburizing, that is, losing the carbon that makes it so strong. And including a piece of paper in here will let what little oxygen is in the pouch burn off. That is, hold on. Pouch secured. I'll let this ramp from 700 to 940 C and let it soak for an hour. And because this is A2, I just have to... As I was saying, I just have to let it air cool before tempering it, letting it soak in some penetrating oil, and we're ready to rock. Now lastly, what good is a T-handle tap wrench without a T-handle? So, here's a T-handle. Nothing much worth showing because I already had a piece of stock at the diameter I needed. So I just had to cut it to length and add a little groove in the middle, which brings me to the final component. A ball detent. This threads down in that threaded hole we touched on earlier and pops into the little groove we put on the T-handle, keeping it in place. And with that, we're finished. It's small, it's simple, and it's one tool. But being done and being good are two different metrics. So let's see if this fixes any of the problems we set out to solve. Test number 1. Do all my taps fit? Yep, this is a good sign. Test number 2, and this is an easy one. Is it smaller than my other wrenches? Yep. So right off the bat, we already have a compact tool that covers a wider range of sizes. Again, why has nobody done this? But I might be getting ahead of myself. We haven't actually used it. Hopefully I won't have to eat my words here. I'm thinking the best test is to use every tap in something challenging like steel. Alright, this is working pretty well, except on the largest ones. This little dinky T-handle doesn't quite feel the best to gronk on. But I haven't revealed all of my tricks. I glossed right over it, intentionally of course, but this square end has a purpose. That's right, it fits in a standard tap wrench, giving me all the leverage I need with a tool I already have. Now this is the real feature I can't believe nobody has added before. I mean, I've looked, no tap wrenches have this square drive. It's painfully obvious once you see its utility, and painfully painful when you realize how simply it could have been added. Same goes for the other things. Some extra holes, making it a little shorter, and a square end. It doesn't get more simple than that, and the impact is huge. I can now get rid of all of these tap wrenches. If you've got a hankering to make the last tap wrench you'll ever need, I'll leave the drawings on my website. I learned a lot during this project, mostly about myself. Over the course of this channel, I've pushed to make bigger, crazier, more complicated projects, and while I think they're cool, designing them, not always so cool. This simple little tap wrench brought me more joy than anything I've made in a while. I got to design just a little bit, I got to machine even more, and I got to think about the story I wanted to tell, keeping my focus right where I want it to be. This is good, for both me and you. So next time you're feeling a little overwhelmed, maybe all you need to do is keep it simple. As always, thanks for watching, and simply, see you next time.
I had an idea for how to do this, okay? I like the wide angle. Okay.
And I'm gonna pull you and I need you to like get all the way out of frame.
Can you grab my shirt?
I don't know if we're gonna get through this.
Should I have had my hands up like I'm...
They need to be like...
Let's see how that looks.
That was good.